Alright guys, today we're going to be talking about matter and its properties. So before we really deep in, just take a look around you. Okay, hopefully right in front of you you'll have paper that you're taking notes on, you're going to have a pen or a pencil, you're sitting in a chair, you're at a desk or a table or something like that. All of those things are made up of matter. But what exactly is matter? Okay, what are its properties? What are its characteristics? What is it? Okay, those are the type of questions that we're hoping to answer in this video today. Alright, so right off the bat, this is our definition for matter. Okay, matter is anything that has mass and takes up space. Okay, so think about all those things that we just talked about. Okay, the pencil, does it have mass? Can you weigh it? Does it take up a little bit of space? Okay, the answer to all those questions is going to be yes. And then mass is how we measure how much matter there is. Okay, so like we've been doing in class, you stick something on a scale, it's going to give you a reading in grams, or if you're at home, maybe it's pounds, but that's how much matter something is, right? Heavier objects have more matter. That just means that there's more stuff packed into that given space, okay? So that's going to be our definition of matter, and we want to make sure that we have mass in there as well. Okay, sorry about that. Get my finger out of the way. Okay, so when we're talking about matter, we break it down into the very smallest parts that we can. Okay, and we break it down into what we call the fundamental parts. So you know how if you're building something out of Legos, the smallest part is just that 1 by 1 section, or maybe it's a 2 by 2, but there are all these little pieces that we start to build off of. Okay, what we call those things are atoms. Okay, now an atom is the smallest unit of an element that maintains the properties of that element. And I'm sure you're very familiar with different elements. You might be familiar with gold or silver or hydrogen or oxygen. All of those are different substances that all of this matter is made up of. Okay, so we're talking about atoms, and those are these very, very, very smallest units of matter. Okay, now a little bit further, what an element actually is. It is a pure substance made up of only one kind of atom. When we're looking at that, we're going to see that it is not made up of two different things. So basically, if you had a bowl of M&Ms, it would be only the red ones. Okay, so it's made up of only one type of something. And conversely, we have what we call compounds. Now, those are made up of multiple different elements or multiple different kinds of atoms, kind of all bonded together, and that's important to say. So we are fusing those things together, and now they just kind of go together all the time. All right, so those are the basics of what matter is and kind of how we're going to be studying it. So let's put those over there. Let's make those kind of the same size. Alright, let's get a little list going. Okay, so if we have those as our basic building blocks of matter, let's write that there just to kind of don't forget it. Okay, so this is the basic building blocks of matter. Alright, there you go. We'll kind of keep that there for a little while. The next part is, and what we're really looking at chemistry, is how does matter change? Okay, if we mix two things together, is something going to happen? I mean, that's kind of the question that we're always asking ourselves. And that's when we start talking about this whole idea of changes in matter. Okay, when we first start looking at it, we need to know first what it starts as, right? If we're going to figure out if something changes, we have to know what did it start at, so that if it changes, we can tell, right? Because if we don't have a starting spot, we're never going to know. So we kind of have these two ideas that we look at, and these are different properties that all matter might have. All right, we have extensive properties, and those are properties that depend on how much matter is there. So that'd be like saying, well, I cut a block of wood so that it was 5 feet long, right? That's some measurement in how long that piece of wood is. Or if we're looking in the lab, I might ask you to grab 25 grams of sodium chloride. Okay, how much of something is there, and then if I take some of it away, right, now we have a new amount that, of our substance, whatever it is. Then on the flip side, we have what we call intensive properties. Now, those are things that are more inherent to the substance itself, and kind of what that means is that it's stuff like the melting point or the boiling point, right? It doesn't matter if we have a gallon of water or 100 gallons of water, they're both going to boil at 212 degrees Fahrenheit or 100 degrees Celsius. So it's just kind of that doesn't make any difference at all about how much of the matter is there. Okay, other intensive properties, just so you can kind of get an idea of what those are, stuff like color, right? A pencil is yellow whether it's the whole pencil or you've sharpened it a whole bunch of times and you only have a little stub left. Okay, so the color really doesn't change. Other things are density, and we really haven't talked a lot about density, but it is how much mass something has and how much space it takes up, kind of the combination of those things. Like aluminum foil or an aluminum cube, they are both going to have the same density as long as they're aluminum. Still other intensive properties is if something can conduct electricity, right? It doesn't matter if we have a long metal wire or a short metal wire, the electricity is both going to go through them. All right, so enough about kind of extensive and intensive properties. That's just going to be our gauge for how things actually change as we go. So again, we'll move those over there. And then the last thing that we kind of want to talk about with matter and its properties is the actual changes itself. Okay, so if we bring that up, this is kind of a long one, so we'll go through it real quickly. Let's go ahead and get this guy out of the way. Okay, all right, so we got all of these things. Now, these are physical properties, physical changes, chemical properties, and chemical changes. Now, a physical property is one where the characteristics can be observed or measured without changing the actual identity of the substance. Okay, so that might be something like the weight of whatever it is, okay, or melting points or boiling points. Okay, those things are intensive properties, but it doesn't actually change the identity of the substance. Okay, and then a physical change is, again, a change that doesn't change what the actual substance is. So if we rip a piece of paper in half, are both halves still pieces of paper? And the answer is obviously yes. Okay, on the flip side, what we have is we have chemical properties and chemical changes, and those relate to the actual substance itself and how it can change. So a piece of paper can burn, right? That would be a chemical property, because as it's burning, if this is now a chemical change or a chemical reaction, because one or more substances is becoming a new substance, right? So if we have paper before, but we burn it, it's no longer going to be paper, now it's going to be ash, okay? Or another example would be if we took, let's see, what would be a good example? Oh, if we took oxygen and hydrogen, they're gases separate, and we ran electricity through them, okay, or tried to light them on fire, well, those would become H2O, right? H2O being water. So we used to have two gases, but they underwent a chemical change or a chemical reaction because of each element's chemical properties. They were able to become a new substance. So really the big difference between these things is a physical property and a physical change just has to do with that substance changing but not actually changing the identity of its substance, right? So not like hydrogen and oxygen becoming water, but like breaking a table in half or dissolving salt into water. It's still salt, it's just now dissolved into water, all right? And then again, chemical changes, chemical reactions, this is where we're creating a new substance. Guys, this is what we are going to be doing in chemistry. Okay, we're going to be looking at chemical changes and chemical reactions, right? That's the why you guys got into chemistry, because that's kind of the stuff that's fun, is we are going to be mixing things together. And we are hoping that they are going to change substance to create something new. Okay, very, very, very last thing that we want to talk about is how we can actually classify matter. Let's get rid of this. Oh, wrong one. All right, so we can classify matter. A lot of definitions on this one. Well, classifying matter is we have, you know, lots of different things that it can be, okay? So we already talked about this idea of pure substances. Okay, those were the atoms and the elements over here, things that are made up of only one type of material. The other things are mixtures. Now, we don't need to really talk a lot about mixtures because that is everything else. A mixture is a blend of two or more types of matter. I'm just going to write that in there. Two or more types of matter. I got a little zealous with my arrow there. There you go. Two or more types of matter, and that's what we're calling a mixture. And really the whole idea with there is we have these things that, you know, the different parts are still individual atoms, okay? They're just mixed together. So kind of think of a salad, right? You could still pick out everything. There's still lettuce in there. There's still carrots, maybe some onions, really whatever you want in a salad. But they're all, you know, their own still unique atoms. It's just that they've been mixed together, okay? And that's what most of the things in our world are, mixtures of those different things. So anyways, regardless, to kind of get back to our idea of matter, we have this first question that says, can it be separated? Well, if it can be, right, so we go over here, we have this mixture, which is something that has two or more types of matter combined into it. And then we have from there two different types of mixtures. One's called a homogeneous mixture, and a homogeneous mixture is where everything is uniform throughout. Uniform throughout. Okay, and those are things like air, sugar and water, stainless steel. Other examples would be soda pop, or maybe a milkshake, right? Everything's mixed together. You can't really see everything that's there. Okay, and then on the other hand, we have what we call heterogeneous mixtures. Now, those are things like a salad, where you can pick everything apart. In general, we're going to say that it looks different, and you can see the different parts to it. Okay, so there's just two types of mixtures. We just kind of identify them as different things. Now, on the other side, if it cannot be separated, what we call it is it's a pure substance. And those are made up of compounds or elements, and that's kind of the stuff over here, right? That an element is only one type of atom, or a compound is two or more types of atoms that have been chemically bonded together. So those are kind of an overview of matter and its properties. We're going to get really familiar with this stuff, guys. We're going to look at a lot of mixtures throughout the year, and then we're going to look really closely at different elements and compounds and try to have a lot of fun with it. All right.